So hello everyone, you are welcome to today's class. So in today's class, we are going to be looking at logarithm. So as you know, logarithm is of it's of two types. So we have the common logarithm, that is the one with four figure tables, and natural logarithm. So the one we are going to make use of the law, strictly law. So but today we are we are going to look at the logarithm with laws. So under the objective, we are going to be looking at laws of logarithm. Then after that, we are going to look at solved examples on laws of logarithm. So let me start by listing all the laws of logarithm. So the first law we are going to consider laws of logarithm. So the first law we are going to consider is multiplication law of logarithm. And the law says log m times n base a equals to log m base a plus the multiplication we change to what? Addition. So log n base a. So as we move from multiplication law to addition, we can as well move from addition to multiplication. The first thing to consider is to consider the coefficient of log of the two logs. That is, the coefficient here is 1, the coefficient here is 1. Once that one is satisfied, you consider the what? The base. Once you have the same log and the same base, the same coefficient of the log and the base, you now take one out of these two, log base A, log base A. So we have log base A into m, addition we change to what? Multiplication by. So multiply by n, which means we move from addition to. So in this case, if it has to simplify, that is, you have two logs, you can have more than two logs, you can reduce it to one log, like this. So that is simplification. You reduce to the barest minimum. So that is that. Then after this, we have division law of logarithm. So number 2, division law of logarithm, that is log m over n base a. So log m over n base a is the same thing as log m base a minus log n base a. So just like the first law, we can as well move from minus to division. Just consider the coefficient of the two logs and consider their base. So once they have the same coefficient, which is 1, the coefficient must be 1. So we have the coefficient here to be 1, coefficient here to be 1. Then take one out of the two logs, so log base A, because they are the same base. But if we have base A here and we have base B here, you cannot factor out any base. So just factor out log to base A because they are the same base. But if they are different base, it's not allowed. So it will now be m minus we change to what? Division. So divided by n. That is from, we move backward again. As we move forward, we can as well move backward. So the next one is number 3. We have power law, log m raised to power n base a equals to, so log m raised to power n base a is the same thing as n multiplied by log m base a. So which is the same thing as n log m base a. So we call it power law. So the next one is zero law. Number 4, log 1 base a equals to what? 0. So log 1 base a, so log 1 base a is what? Is 0. Simply because we are not there yet. We are going to do that under relationship between indices and logarithm. But log 1 base a, according to the laws of logarithm, is what? Is 0. Then the next one is number 1, 2, 3, 4, 5, then number 5. So log A, or you can say log M base M. So once the number and the base are the same, so we have 1. We call it unit law. So unit law in the sense that the answer is what? 1. So it means when you have log 100 base 100, the answer will be 1. Log 1 million base 1 million, the answer will be 1. So once the number and the base are the same, the log will be 1. The log will be what? 1. So the next law is change of base law. So change of base law. So when you have log m base n equals to log m base a all over log n base a. So what brings about this is when you cannot express the number in the base of the same given under the log. That is when we are going to change the base to the suitable base for both numerator and denominator, or for both m and n. So once you cannot express the number m in the base n, so we are going to change base. If there is no way we can express log m in base n, you know we have base n here. You cannot express m in the base equal to base n. So we are going to change the base to the convenient base. And that convenient base will now be log m base a. It means we can express m in base a, and we can also express n in base a conveniently without problem. So we are going to move to the second objective, which is solve examples on laws of logarithm. So which is going to be in form of simplification of logarithm. So in form of simplification of logarithm. So example. So the first example is simplify log 1000 base 10. Log 1000 base 10. So we have two ways of solving this. So the first thing to do is to express solution. We have log 1000 base 10, which is equals to log. So 10 in how many places will give us 1000? That is 10 times 10 times 10. So we have 10 times 10 times 10. So base 10. So 10 times 10 times 10 base 10. 10 times 10 times 10 gives us 1000. So log 1000 base 10 is the same thing as log 10 times 10 times 10 base 10. So making use of multiplication law of logarithm, we are going to open this bracket with log to base 10. So we have log 10 base 10. Multiplication will change to what? Addition. Then plus log 10 base 10. Log 10 base 10 plus the last one, log 10 base 10. So which is equals to, from the law of logarithm, that is law 5. Log 5 says log m base m equals to what? 1. It means when the number and the base are equal, the log will be equal to 1. So log 10 base 10 is 1 plus log 10 base 10, 1 plus log 10 base 10, 1. So which is equals to what? 3. So it means log 1000 base 10 is 3. So this is one way of solving this type of question. You can use the second method, which is log 1000 base 10, which is equal to log, just express 1000 in base 10. So if you express 1000 in base 10, it's going to be 10 raised to the power of 3 base 10. We now make use of what? Make use of power law. That is the third law, power law. So we have log m raised to power n base 8. So n will come to the front. That is n will now multiply the log. So the same thing applicable to this, which is equals to 3 will come to the front to multiply the log. That's 3 multiplied by log 10 base 10. So which is equals to 3 multiplied by Log 10 base 10, when the number and the base are equal, the log will be equals to 1. So which is 3 times 1, 3. So you can use any method you like out of this 2. Then question 2. So example 2 says, using example 2 says evaluate log 6 base 10 plus log 45 base 10 minus log 27 base 10 without logarithm tables. So the question says evaluate log 6 base 10 plus log 45 base 10 minus log 27 base 10 without logarithm table. So to do this, write down the question. So the question is log 6 base 10 plus log 45 base 10 minus log 27 base 10, which is equal to, so as we have it here, we are going to move backward, which means we want to reduce the number of logs that we have here. We have 3 logs, we now want to simplify it, we want to reduce it to the lowest step, that's to evaluate or attempt to simplify. So the first thing to do, I've told you, if you have to move backward, we have 2 things to consider. The first one is the coefficient of the logs, while the second one is the base. The coefficient must be 1 or true, before you can pick one of the logs out of the log. Then they must have the same base. It's very important. So if you look at the question given, they are of the same coefficient, the log are of the same coefficient, and they are of the same base. So you have to pick log base 10 into bracket. So the into bracket what? 6. Addition will change to what? Multiplication, multiplied by 45. Then minus will change to what? Division, divided by 27. So which is equals to log base 10 into 3n to 3n 9. Then 9n 1, 9n 5. So we are left with 2 times 5. So that is log 2 times 5 base 10. So which is equals to log 2 times 5 is what? 10. Then base 10. Log 10 base 10 is what? When the number and the base are equal, the log will be equal to 1. So it means log 6 base 10 plus log 45 base 10 minus log 27 base 10 equals to 1. So this is example 2. So let me give you another example. And the question says, simplify log 10, no base there, minus 2 log 1 over 5 minus log 2.5. So if you have question like this, it's automatically in base 10. So if you are given any log to base, any log without base, in this form, the base here is base 10. So we have base 10, we have base 10. So log 10 is base 10. As we don't have any base, so we regard this as log 10 base 10. Then minus 2 log 1 over 5 base 10. We have invisible 10 there. Then log 2.5 base 10. So that is that on the question. So let's now solve. Solution. So the question is log 10 minus 2 log 1 over 5 minus log 2.5. So I've told you the logs are in base 10. So that is the first condition. So the logs are in base 10. That's the first condition. Then the second condition to consider is to check the coefficient of the logs. So the coefficient of the first log is 1. The coefficient of the second log is 2. The coefficient of the third log is 1. So we are going to make the coefficient of the logs to be equal by using a power law, the reverse of the power law of logarithm. That is law 3. So we are going to move from this back to this. So we take this n to be the power of the number given. So we are going to have it as log 10 minus log 1 over 5 raised to the power of 2. So we transfer this one here. That is that. Then minus log. Then the next thing to do is to change this decimal to fraction. So we have it as 25 over 10. 25 over 10. Then after that, we have the coefficient of logs to be equal, which is 1, 1, 1, 1, all true. Then we have their base to be what? Equal. So we can simplify further as log 10 minus log 1 square 1 all over 5 square 25. Then minus log, so we can reduce it to the lowest end, which is 5 over 2. So 5 over 2. So from here, if you like, you can use division law here, division law here of logarithm. That is log m over n. Or if you like, you can just factor out log to base 10 and simplify. So let me use division law of logarithm. So we have log 10 minus, we have big bracket here. So log 1 minus we change to what? Division we change to minus. That is log 25. So that is that for that. Then close the bracket minus log, the same thing here, log 5 minus log 2. Then close the bracket. So you now open the bracket with minus. So which is log 10 minus log 1 plus log 25 minus, so we are done with this, move to the next one, minus log 5, then minus times minus plus log 2. So from here, we are going to have so all the addition, log 10 plus log 25 plus log 2 minus log 1, then minus log 5. So from here, log is common, then 10 times 25 times 2. So 10 times 25 times 2. Or you can say from here, or you can say log 10 is 10 is 1, then plus log 25, that is log 5 raised to the power 2, then plus log 2 minus log 1. Log 1 is what? Log 1 base 10 is 0. So we have 0 there minus log 5. Then from here we have 1 plus 2 will come to the front. So we have 2 log 5 plus log 2 minus log 5. Then if you collect the like term, we have 1 plus 2 log 5 minus log 5. That is log 5 plus log 2. So from here now, you can just factor out these two log. So it's now going to give. So from here, we have 1 plus log 5 plus log 2, which is the same thing as 1 plus, just take 1 out of these two log n to 5 times 2. So we now have 1 plus log 10. Then it's just like log 10 base 10. So which is equal to 1 plus log 10 base 10 is 1, which is equal to 2. So the answer is 2. Then we have short form of solving this, and the short form is this. So log base 10, log 10 minus 2 log 1 over 5 minus log 2.5 base 10. I've told you log without base is in base 10. So we now have log base 10, log 10 minus log 1 over 5 raised to power of 2. You transfer this here, transfer it to become power. Then minus log, change the decimal to fraction, we have 25 over 10. Then you now, simplify before you log 10 minus log 1 square 1, 5 square 25. Then minus log, reduce this to the lowest and that is 5 over 2. So making use of, once they have the same coefficient and they have the same, they just take 1 out of the 3 log n to 10. Minus we change to division divided by 1 over 25. Minus we also change to division divided by 5 over 2. Then which is equals to log n to 10. Change the division to multiplication, that is multiplied by 25 over 1. Then multiplied by 2 over 5. So which is equals to log n to 5 and 5, 1, 5 and 25, 5. So we are left with 10 times 5 times 2 times 10. So which is equals to log 10 plus log 10 using multiplication law of logarithm. So which is equals to 1 plus 1. 1 plus 1 is also 2. So we have the same answer. So it's either you use the log method or you use the short method, depending on the one that you understand most. So thank you and God bless. So if you find this video interesting, please subscribe to the channel and give us a thumb up. Thank you and have a nice day.